Hi, folks. Good afternoon. We'll still see people rolling in after lunch, right? But we'll get started because there are sessions scheduled like back to back. So for those of you who were not there this morning for the other session, I'll reintroduce myself. So I'm Pallavi Priyadarshini. I lead engineering for the OpenSearch project and the Amazon OpenSearch service for a portfolio that includes search, security, dashboards, and releases. And I'm super excited to bring this session to you because we recently revamped the OpenSearch roadmap in open source, and it was all done using a public process, right? And we had a blog, and we have recreated the GitHub project roadmap that has all details of our plans for this year going into next year, right? Some of the long-term projects are also captured there. And when I say we, it's not AWS or anything, right? The roadmap is built in the community with the help of maintainers and contributors, right? So just to recap a little bit, most of you are familiar, but this will just level set. So OpenSearch is a fully community-driven, open-source search and analytics suite, and it was derived from Apache 2.0 licensed, Elasticsearch 7.10.2, and Kibana 7.10.2, right? And it is a distributed search engine. We are based off the Lucene search library. And we also, apart from the search engine, we have a UI component, which we called OpenSearch dashboards. And along with the core OpenSearch and OpenSearch dashboards, there are a bunch of tools and plugins that implement different functionality. So OpenSearch is like a big ecosystem of different features consisting of core, dashboards, and a lot of plugins and tools. Now, this is the biggest news that has happened to us in a long time. So OpenSearch got transferred to the Linux Foundation, and we call it the OpenSearch Software Foundation now. And as you caught it in news last week, it was announced at Vienna Linux Foundation Summit, right? So this was a big deal for us because we truly believe in the true spirit of open source. We don't want any one vendor to be dominant or control the governance, right? So this move to the Linux Foundation will allow a more vendor-neutral development. And we are working with different partners and founding members who have joined us in the foundation to actually help create the roadmap and do deliveries as well, not just create the roadmap. Now, a little bit more about the use cases. So OpenSearch is a platform, is a general purpose platform that serves multiple use cases. So obviously, fundamentally, we are a search engine, right? So search and ML is the primary use case that it serves. Observability is another big one, and most of our users use it for search or observability, right? In observability, you're dealing with a lot of machine-generated data that we have to ingest at high speed. A more recent addition, an emerging use case, is security and security analytics. We have users and customers who want OpenSearch to help them with their threat detection, right? And I'll talk about it a little bit more later on. Now, I do want to reemphasize the open source spirit of OpenSearch. When I say we are fully open source, there's nothing hidden about it. We want to be fully transparent to the community, right? So the roadmap we created with community input. It was a public process. Then there are hundreds of community contributions that come from external contributors. We have external maintainers as well. And the maintainers come from different organizations. We have Logs.io, Ivan, these are just some names we put there, but there are more, right? And we are 100% open source. We are Apache version 2.0 licensed, which means you can use OpenSearch, you can modify it, as you like it, you can monetize it, and many vendors are doing that, right? There is no additional licensing we do. Even as a contributor, anyone is free to contribute to OpenSearch. There is no additional contributor license as well. There are multiple service providers who use OpenSearch and have offered them OpenSearch as a cloud-based deployment, in different cloud environments, like in AWS, Azure, Oracle, GCP, all of that. Now, one thing that truly differentiates us from other equivalent open source projects, we are full-featured in open source. So most of the features we develop, in fact, all of the features that touch the data plane of OpenSearch software, we have taken it as a tenet that we will develop the feature in upstream first, which means all the data plane innovations go in open source, right? And that's why we open the RFCs, make it very transparent that we are working on this. So we support full text search, all the analytics use cases. The emerging area we have been focused on is machine learning. And under machine learning, we have a lot of new features that have been recently developed in the last year or two that focus more on the semantic search, vector search, setting up anomaly detection, alerting, etc. As part of the full features, we also focus on the security and the high availability, right? So these are not like enterprise features which are not available in open source. Within our open source software, if I take security as an example, using the security plugin, you can configure like fine-grained access control, you can do document level, field level security, you can set up audit logs. All of that is in open source. So now this is something new we did like a couple of weeks ago. So what we did was, we are scaling as an open source project. There are lots of requests coming in from external contributors also. And the number of RFCs and issues we have, it was hard to even track like who's doing what. And we want to give a clear picture to the community that this is the direction we are headed in, right? And obviously this is done with a spirit of getting feedback and even getting contributions. So we, in open source, like this was all discussed on a GitHub issue, these are the different themes we agreed on, and we decided to organize our roadmap. So these are the 9 themes that we agree on, and I'll quickly walk through some of the, actually all 9 themes at a high level. So the first and foremost, and the reason I put it as number 1, because that's a relatively new area where we are seeing a lot of uptake, right? So vector and GenAI is a theme that has emerged in the last 1 or 2 years, right? And we have many features to support this theme. And then obviously there are a bunch of others: search, ease of use, observability, log analytics, cost performance scale, stability, availability, resiliency, security, modular architecture, and last but not the least, releases and community health. Because like I said, as an open source project, we have to scale to the number of repos we have, the number of contributors, so we also need good mechanisms to manage the releases and project health. So I'm moving on. I'm kind of going to talk about vector, GenAI, and search together. So this is search as we knew it all along, right? This is text search. This is the keyword search which we all were used to. So basically, the search engines would just match the exact term or keywords to a catalog of terms, right? Now, OpenSearch works on top of Lucene search engine. So obviously, there's other stuff, like there is a notion of search relevance, which is calculated based on the frequency of the terms, right? And there is some other algorithms like the BM25 that is used for computing the search relevance. Then there's also facets that allow you to drill down into the search results based on the attribute value. So what changed? So obviously, I don't have to spend too much time here because we all know what's happening, right? So obviously, search was, important to a lot of people. But what changed in the last, again, couple of years is the emerging, large language models, which power a new wave of Gen AI-based search use cases, right? So with LLMs, now you can have more conversational or more natural language type of search supported, right? And we want to make some of these use cases accessible to a lot more users. It doesn't have to be just experts in DSL or PPL, right? So obviously, there's also this new, no-code search flow builders and query assistants that have come up. And I'll talk a little bit about that. So AI is not going mainstream. It has already gone mainstream, right? And thankfully, we were invested in this area at the right time so that we have a lot of features that we have unveiled in the last couple of years to support these new use cases. So a little bit about vector similarity search, right? So the Gen AI models, they represent unstructured data. You can have audio, text, video, PDFs, whatever it is. They represent them as vector embeddings. And now, these vector embeddings are capturing the semantic meaning and also the relationship between them. So now the concept of search, you're actually computing the distance between these vector embeddings. You're calculating the proximity between these vectors, right? So search, the meaning of search when it comes to vector embeddings is slightly different, although conceptually it's still the same. So on a high level, I'll just spend a couple of minutes here. This is how a vector search workflow would look like. You can have your raw data, which I said can be unstructured, audio, video, whatever it is. In the vector search workflow, typically it is split in chunks in the indexing flow, right? And the chunks are fed through the transformer models to generate the vector embeddings. And OpenSearch actually indexes these vector embeddings and stores it as a vector database. And after that, and this is what we call the KNN indices, and these KNN indices are then available for search use cases. And let me talk about a little bit about the search side of things. I mean, here I have taken the example of a chatbot, but it could be different types of search experience as well. So in a chatbot, you ask a question, and the question gets converted to a vector embedding, again, using the same transformer model. And then it goes through the OpenSearch vector engine, right? So the semantic search flows uses the KNN plugin to do the KNN search on it and return the texts or documents which are also ranked, right? Now, these returned text or documents can serve as enriched prompts to LLMs, which in turn generate your answer. So it looks a little bit complicated, but OpenSearch makes it easy for you. So let's talk about what we have coming up, remaining 2024 and also going into 2025 in this vector search and Gen AI space. So again, vector embeddings are big resource and they do consume resources. So disk-optimized ANN is one area where, we're trying to optimize on the memory consumption, right, of these vector embeddings. So disk-optimized ANN will have a concept of like a two-phase search where in memory it's just your quantized vectors, right? And the initial KNN search is run on those quantized vectors. And then there is a next level of search that happens with the full precision vectors stored on the disk, right? And along with that, there's a bunch of other memory optimizations that's happening for the vector search area because, again, memory is a big resource consumer there. So there are different types of quantization techniques to optimize memory. Then on the indexing flow, Indexing is expensive, and like it can take you hours to build vector indices, right? So there are conversations on using GPUs on the indexing flows for vector. Then there is an integration happening. I mean, I can see people who are here who are helping out with that. Integration happening with the warm tier for vectors, right? Then the other area we want to, apart from price performance, out-of-box experience, like the usability. There's so many of these hyper parameters that can be tuned by users, right? We want to make it easy, and we want to ship with intelligent defaults or have integration with auto-tune that can adjust these parameters to tune. Alongside all this vector search improvements, there are other improvements on the AI ML search innovations. So neural search, for example, is going to support offline batch processing for inference services like SageMaker, Cohere, OpenAI, etc. Neural sparse search is another kind of semantic search that has recently come up, where you're not representing your data as dense vectors, but you have more sparse embeddings, right? So it's come up recently and is being explored more and more by customers and users alike. Now, one more thing that we want to focus on is the development process for builders, because we know, like, plumbing some of these workflows can be difficult, right? So we want to focus on how we can make it easy for builders to quickly stitch together Gen AI-powered search experience. So with that in mind, there are some low-code search flow builder that has been unveiled for creating AI ML search experiences and dashboards more easily, right? Then there is this whole OpenSearch assistant, which will allow you to create your own chatbot or query assistant applications. I mean, it's a very customizable toolkit. So this was all on the vector and Gen AI, and there is close relation with the core search, because a lot of those newer workflows end up using core search APIs on the ground. So on the core search side, we are working on a composable query engine with a new query planner. Again, there are people in the room working on it, like the maintainers working on it. So we don't typically, like with Lucene and the legacy OpenSearch software, we don't have like a good query planning experiences, which most data management softwares have, right? So we're working on this query planner that can do sophisticated optimizations on different types of queries, right? And we have seen the kind of workloads. I mean, it can range from complex aggregations to it can be sub 10 millisecond latencies. Like, we were dealing with a workload that does NFT transactions. So 5 to 6 millisecond is the SLA, right? So we're dealing with a range of workloads, and what we have seen is by tweaking the type of parameter, some query parameter, the performance can vary quite a bit. So we are building this query planner that will do more heuristic-based planning for us. Then along with the query planner, there is a native join capability. Again, it's a different set of use cases, and we get this requirement from a lot of the users who deal with security analytics data, who want to join data across indices, right? Then there are a lot of infrastructural improvements which should help in performance. Like, we're separating the search coordinator logic from the Lucene shard level coordinator, shard level logic, right? Query performance is a big area of focus for us. And it can be term, multi-term. I think yesterday Fro had a talk on this. Term, multi-term, range, aggregation. We're looking date histograms. There's a slew of things we are working on in this space. And it's not just these optimizations to these specific type of queries. The way we are building the new query engine, we will be able to support newer languages, such as Rust. So the new components we are building out, like the new coordinator, is going to be implemented in Rust at some point. And then it can also support more parallelization with SIMD. Then concurrent segment search was another thing that we recently unveiled, but we are making it out of box. Again, a lot of people here have helped making this possible. And it can be tricky because while you have all these optimized algorithms like concurrent segment search, but we also need to take in account like the resource consumption of the cluster, for example, before you can really leverage things like concurrent segment search, right? And there's a new star tree index that's being worked on as we speak. And along with all these improvements in the query engine and query performance, there are new capabilities we are adding on the search side of things. So new field types, we are introducing derived fields, bitmap filtering, wildcard fields, etc. Query insights is another area because when you run these workloads in a real production environment, most of the administrators have no idea what's running on their cluster-based system, right? So this is a mechanism for them to identify the problematic query, right? And I'll talk a little bit about it later on. Then Lucene is another area where we are focused on. We want tight integrations with Lucene. We are picking up more and more innovations from Lucene, and not just that, we are contributing back to Lucene, right? I mean, it is like the core search library we have, so we need to be tightly integrated and contribute back to Lucene as well. New algorithms for search relevance, like BM25F. It's no longer just BM25. Hybrid search enhancements. So like I said, now search has a much broader meaning, right? So most of the real use cases we see, they're trying to combine like lexical search with some form of semantic search, right? So in this hybrid search workflow, I mean, there are things you could do to do better search relevance across the different type of searches, right? Or you could do deeper profiling so that you know exactly how much time is spent in these different parts of the hybrid search. User behavior insights, I think there was a talk early on today. So again, with all these, the new search types we are seeing, there's a lot of opportunity to tune things on the fly, and that we can do if we record the user behavior, right? Then on the data prepper side, there are enhancements happening so that OpenSearch becomes a de facto search engine for all like SQL and NoSQL databases. So there are active integration work happening with other databases like Dynamo and RDS. So data prepper is helping us do that. Okay, so the next theme I want to quickly cover is ease of use. So I'll go a little faster because I want to leave a few minutes for Sam to actually walk you through the process, how you can contribute. Ease of use. So this is a big area of focus, like usability, ease of use, because we do want to be a product that all types of users should be able to use, right? It's not just those expert users or power users. We want even novice users to be easily, we want OpenSearch to become more accessible, and Dashboard is an easy way to do that. It's a very powerful tool. So we are working on a unified dashboard experience because most of the real production deployments of OpenSearch, they deal with multiple deployments, multiple OpenSearch cluster or serverless collection, and they want to manage everything from a single pane of glass, right? So we are giving Dashboard an uplift to support multiple data sources. This is a very simple view of what it'll look like, right? So you might have, for a cluster-based environment, you might have like different clusters having the sales data for different regions, and you want this one dashboard where you can see how you're doing on sales across different regions. Now, apart from this whole multi-data source experience, the big shift for us is we are redesigning Dashboard to make it more accessible for different types of users, right? So we are going to introduce curated data visualization experiences for different types of users. So if you're a search user, you're an observability, if you're a security analytics, we have different flows integrated in dashboards with different templates, different getting started to make it easy for you to use dashboards. Workspaces is also a new concept which we are introducing, which will make collaboration easier. So you have all the saved objects and dashboards. So Workspace will make it easy for you to logically arrange those saved objects and share it across users. And again, within Workspaces, you will have different entry points for different types of users, right? For different types of use cases like search, security, analytics. Now, on observability and security analytics, so this kind of ties, that's why I put like the dashboard stuff earlier than this. So you want to correlate your logs, traces, metrics in one place, right? And you want to find that needle out of the haystack, right? So there's a lot of investment going on here to make our observability flows much better than what it is today. So there's integration with like OpenTelemetry that is like an industry standard for ingestion of logs, traces, metrics. Unified query experience, this is very important, right? For different interfaces like DSL, PPL, right, or SQL, we want them to have a unified query experience within Discover, right? And talking about Discover, we want Discover to be like the single entry point for your different analytics experiences. And there's a lot of work that the team is doing in this space. Like from within your Discover, you should be able to, write queries, refine them, and move to like creating, visualizations. You can create alerts, etc., and all within Discover. Okay. Then there is this whole thing about making OpenSearch more cost-effective if you have a lot of data already sitting in a data lake. So there are integrations happening with Apache Spark so that you can query the data that is stored outside of your OpenSearch. Then there are enhancements to Data Prepper as well. Data Prepper is looking at more ways to bring data into OpenSearch, and not just that, it's going to support more syncs, such as Kafka. Security analytics within OpenSearch, again, we want the experiences to be more powerful and intuitive, and there are integration of GenAI workflows within the security analytics experience. Cost performance scale, again, a big theme. Search performance, I kind of already touched upon it, so I'm not going to repeat myself, but all I'm going to say is, apart from the query type and the Rust and SIMD, there is a bunch of work happening on the reader-writer separation, which should help. Along with performance, it should also help with the scale in independently scaling your writers and readers. Then there is this protobuf implementation going on, which is more efficient than the textual parsing that we do. There are application-based templates we are shipping because, again, OpenSearch is a general platform, can be used for different use cases. So these templates kind of understand what you're using it for, and they can guide the workload better in terms of what defaults or what kind of indices, etc. Shard management is another area in terms of scale. We're working on more intelligent ways to split the shards, right? And make those placement decisions on the fly. Pull-based ingestion, I kind of touched base on this morning. We'll look at offering alternative APIs because with the pull-based ingestion model, you can scale your index writers better, or you can do prioritization of your indexing workflows. Okay? Remote storage and automatic tiering, again, covered this morning. We already have remote store today, but it's only used for durability, right? So we want to remove the tight coupling between your local store and remote store, right? And we want to introduce more seamless data tiering across hot, warm, and cold, where it integrates with the data lake. Snapshots will be much faster, smaller, less resource intensive because it's all going to work from the remote store. Cluster Manager is seeing a bunch of changes so that your admin APIs are less intensive on the resources. Really quick, stability, availability, resiliency, another area. Again, a lot of folks here are working on it. We want full visibility into different phases of the query execution. So there are new metrics at the coordinator level. Query insights, we recently rolled out top-end query categorization, but there is a long way to go because we want to make an intelligent recommendation engine that can suggest to users how to tune your queries, or even better, auto-tune the queries, right? Then query resiliency, while we had some form of search back pressure and cancellation, we needed to go deeper because your execution could be in the leucine layer. So we are introducing better mechanisms for search back pressure and cancellation. Workload management, we're introducing query groups using which you can actually assign prioritization to your different tenants. Right now, there is no separate quality of service for different services, for different tenants. So with workload management and query group introduction, we can hopefully get to a different quality of service depending upon the priority. Cluster state management, I sort of covered that we are breaking the cluster state into smaller pieces so that each service only consumes what it needs rather than this monolith cluster state. Then the data prepper is also getting enhanced such that the DL queue, the dead letter queue, is much better. In case OpenSearch is down, it can handle those scenarios. Security, we are strengthening the plugin. OpenSearch has a lot of plugins. So we want granular control over, if multiple plugins are sharing resources, then admins should have full visibility into the permissions that a plugin is requesting before installing a plugin. Optimized privilege evaluation, again, a recent big topic because you might have complicated scenarios like many indices or many roles, and we want the privilege evaluation to be super fast so that it doesn't become like a bottleneck, right? We are working on index-level encryption. Each index can have different, customer-provided keys. Security setup, ease of use, that continues to be a pain point, and we are working towards improving that. And hopefully, we can do security setup through dashboards. And we want to move to a completely pluggable model where even the auth-z, models can be plugged on the fly, right? Like we can adopt newer policy evaluation algorithms like OPA more easily. I won't speak too much about this. I covered this in the morning. We are re-architecting to move to a more service-oriented architecture, right? And there's a lot of work going on here as well. We have, on the releases and project health, we have unveiled new operations dashboard because, again, the project is scaling with many repos, many users. We need to make it easy for every component to do their own operations, right? So we have unveiled new operational dashboards, and it's all in open source. Every component can look at what are the outstanding PRs, how many untriaged issues, and all of that. Release process is very important to us. We want to stick to the 6-week cadence as much as possible, right? And we want to make it easy for anyone to release OpenSearch, right? So there's a lot of work going on, no manual sign-off. The CI/CD pipeline should stay green. We have a new release dashboard to show the health of the pipelines as well. So with that, I'm going to hand over to Sam, and I should have introduced him earlier. He's a senior principal engineer with OCI, and he's going to take you through the process on how you can contribute more. Thank you.
Hello, everyone. Thank you very much for Pallavi for walking us through this amazing, extensive, exhaustive roadmap. It is one thing that is important to keep in mind. This roadmap is a living document. It was done thanks to community involvement and engagement. And we're going to walk through this process to make sure that is still going to be the case. So we can still keep making it better as we go. So I'm just going to go, actually, before we get there. So one more thing about myself. I'm also a maintainer on OpenSearch on certain projects, and also I was a member of the leadership committee. And one thing that I think about when I think of this process, the way I see it, is a way for us as community members to continue to participate and to continue to contribute regardless of where we work, what we do. So at every given moment, we can always open this roadmap. We know what the process is. We know exactly what's going on. We know where we can help, and we know where we can suggest new improvements. This is kind of the purpose of what we're going to look at. Okay, so the first kind of easiest thing you can do that we've always been doing so far is you can always just go and create an RFC. RFC, basically you have an idea, you have a suggestion, just create an RFC, you can describe it there. Some RFCs are super detailed, like they have everything from like the problem statement, design, a whole work plan. This is not mandatory. You can create an RFC, it can be as lean as possible. It's kind of like very open format. However, if you have a more concrete thing that you want, like for example, you want to introduce a new feature or you want to have a new roadmap item that you think needs to be included, then we have the new feature template. So you can create a new feature request, a new feature issue. And with this template, we're gonna walk through it pretty soon. This is how you can request those. And again, the idea is we don't want to create a process for the sake of process. We want to make things with minimal overhead as easy as possible, get as much engagement and involvement from the community. So when you create a new feature request, we do ask you to fill in several things, right? So one thing we want is, first of all, to just understand, right, what the problem that we want to solve, like what is the suggestion, what is the improvement, and also that's actually very important is to make sure that it is a good fit with, you know, like the overall of what we're doing in the project, and also to make sure that it's not redundant, right, with other things. The last thing about it that's kind of a weird wording is atomic. It doesn't mean that, you know, it will detonate like a nuclear bomb or something. What it means, it's just that it's kind of like an independent, kind of self-contained thing that you can later break into work item. It's not like you know, if we do this and we have to change like a million of other things, but something really that is easy to reason about, easy to kind of, you know, put like some scope boundary to it, and we can really break it later to like smaller chunks of how we address it over time. Okay, so as mentioned, we want to make it as easy as possible, so you can always send those, especially the new feature request. You don't have to provide a design doc. You don't need to create a pull request. And the only thing is really just use the template, because that's very helpful. One thing to kind of make sure that is understood is, like, you know, if we create something like a new feature request, then there is no guarantee, right, that it will like get picked up tomorrow, right? It's really up to you and other community members of when it will get picked up. So after we create the new feature request, so there's going to be a discussion, right? So there's going to be discussion among maintainers, among community members, and then after the discussion, you know, we'll say, okay, that fits all the criteria, this is a valid feature request, and we eventually can elevate that to a roadmap item. And basically when the community sort of like in a consensus and agrees, then we can get started with the actual work. So this is not mandatory per se yet in our rules, but one thing I find pretty helpful is once the work begins, you know, especially it depends if it's something like super small, like I don't know, like you want to fix a bug, then maybe that's not necessary. But for things that are bigger, of like larger scope, it's really important to have a design to make sure we create meta issue, and and then we create individual issues. Now, the reason we want to do that is because we want to really help, we want to make sure that this feature can get worked on by as many people, so it can get delivered faster. And again, it makes the transparency better, the collaboration in the community, and that's it. Oh. All right.
Okay, so that pretty much brings us to the end of the session. But like I said early on, last week was very big for us with our move to the Linux Foundation, and we want to see more contributions coming from the community. And we want to build up like the external maintainers as well. So we went through a lot of roadmap items. All of it is there in the release board. And blog, just for whoever is interested, you can go through each theme, whichever interests you. And most important, if you want to see any change, right, to the roadmap, to the process, we are open, right? Nothing is fixed here, and we really value community feedback. So we'd truly appreciate if you find ways to get involved, right? And we'd love to have a repeat of this, saying that we increased our external maintainers by so many numbers, and we'd love to be in a position to say that. So our vision is OpenSearch will be the most optimal cloud-native data platform, and there are other external contributors and even big companies who are helping us get there. So thank you very much for listening today, and if you have any questions, we're around. Okay, thank you.